Alrighty, guys, we're going to take a look at 4.2 today, solving quadratic equations by graphing. A few things we're going to kind of look for. Obviously, in 4.1, we learned how to graph. Today, we're going to solve those. And if you recall from the last 2 days of us talking about things, when we solve quadratic equations, we are looking for the corresponding x-intercepts. All right, so let's dive right into things. Solving quadratic equations. Taking a look at example 1, it says solve the equation by graphing. So we have x squared plus 4x equals -4. If you recall from section 4.3, we talked a little bit about this. If we want to solve, our equation does have to equal 0. So I'm going to move everything over to one side. All right. So I have my quadratic equation. If we want to substitute in y instead of 0 there, that is a-okay. But then we need to graph. Okay, I'm going to choose to graph this using our shortcuts we learned in 4.1. So first things first, finding the vertex and my axis of symmetry. If you recall, our axis of symmetry is always going to be -b over 2a. So if I have -4 over 2 times 1, that is going to be -2. So my axis of symmetry is at -2, which means the x-coordinate of my vertex is -2. So then I need to plug in -2 for my x's. -2 squared is 4. 4 times -2 is -8 plus 4. Check it out, 0. All right. So we have our vertex. We have our axis of symmetry. The last really easy thing to find is our y-intercept. And again, our y-intercept is where x is 0. So if I plug in 0 for my x's, I'm left with a 4. So I have -2, 0 is the vertex of my graph. I have my intercept at 4. I know my axis of symmetry is at x equals -2. And I can use this idea of reflection to bring my y-intercept over to the other side, and I can graph my parabola. All right, looking at this situation again, if we're solving this by graphing, I am looking for the x-intercepts of my graph. All right, hopefully you notice at this time, my solution is -2. There's only one answer. It touches the x-axis at -2. Again, keep in mind our solutions are the roots, solutions, x-intercepts, all of these words we're going to kind of use interchangeably. And actually, I'm going to introduce a new one. It's called zeros. We'll get to that more particularly next chapter as far as things go when we talk about polynomials. Okay. So we kind of use those words interchangeably. So if I ever ask you for a root solution, x-intercept or 0, just know you're looking on your graph for the x-intercepts of that function. All right. Continuing on, we're going to solve these next couple. All right. So it says find two real numbers with a sum of 6 and a product of 55. So I'm thinking two numbers, x and y, have a sum of 6. I also know that they have a product of 55. All right. So I'm kind of setting this up. It says find those or show that no such numbers exist. Check your answer by factoring. All right. Well, at this stage of the game, we have a system of equations. So I'm going to take my top equation. I'm going to set y equal to 6 minus x. Then I'm going to substitute things in. So if I take this, I'm going to have x times 6 minus x equals 55. After we distribute, we have 6x minus x squared equals 55. And like we said before, we need to make sure our equation equals 0 in order to solve. So I have x squared minus 6x plus 55. And now my goal is to figure out how I can solve and factor that. All right. Well, if we kind of think about things, I'm looking for two numbers that multiply to 55 that add up to -6. So I'm thinking 1 and 55, 5 and 11. Hey, 5 and 11 work if 11 is negative and 5 is positive. All right. As we take this to the next step, our solutions are factored. It looks like one answer is possibly 11 and the other answer is negative 5. All right. So those are the two numbers for x. Find two real numbers such that the product is 55 and the sum is 6. If we look at those two solutions, hey, they work. All right. Next situation, we're going to try the same thing here. So we have a sum of 15 and a product of 63. So we set up our two equations, and then our goal is we need to solve. So we're going to solve the system just like we did before with substitution. I'm going to take my top equation, solve for y, which means y is 15 minus x. I'm going to swap it into the next one. So I have x and 15 minus x equals 63. 15x minus x squared does equal 63. And like we said before, we need to get everything on the same side in order to factor and solve. At this stage of the game, I am looking for two numbers that multiply to 63 that give me 15. So I have 1 and 63, I have 3 and 21, I have 7 and 9, and that's the extent of my list. If you noticed, well, none of them work, so factoring does not work. So at this stage, I'm thinking my answer is no solution. Okay. Some of you might be wondering why I threw the graph in here. If you look over at the graph, this is actually the function x squared, or sorry, that's negative x squared plus 15x minus 63. I graphed kind of its opposite. Remember, we moved everything over to the right side, so we had a negative, or excuse me, a positive x squared. All right. So when we look at this function, all right, it's the same equation we just solved, but with a factor of -1 in it. You'll notice there are no x-intercepts on my graph, hence the case of no solution, which kind of brings me to my summary here. If you notice, our first example did have one solution. Our second example had two solutions, and our third example had no solutions. So if you need to get this in your notes, I would write it down. But parabolas can have one solution, two solutions, or no real solutions. And remember, those solutions are the amount of times it touches the x-axis. All right. With that being said, we're going to go into our final example of the day, looking at estimating solutions. All right. So the height of an object is given by this equation, -16t squared plus 48t plus 400. All right. A lot of what we're going to do today is looking for something like this, the maximum height of the object. Well, you're thinking, oh man, where's the maximum height of an object? If I have a parabola that starts at 400 and kind of opens down like this, again, it opens down because we have that negative. The highest point is going to be, hopefully you're seeing that, is the vertex. All right. Again, the vertex we calculate by doing -b over 2a. All right. When we run that calculation, -48 over 2 times -16, we get 1.5. All right. Then what we do is we plug 1.5 in for each t. So we have -16 times 1.5 squared plus 48 times 1.5 plus 400. And we wind up with 436, which means the maximum height of this object is 436 feet. All right. The other question we can ask you today is not the maximum height of the object or the vertex, if you will. And when we talk about word problems, the other situation that may arise is how long an object takes to reach the ground. Well, if we're talking about our graph, where's the ground? Oh, you are correct. It's at 0. All right. So if we're looking for when it hits the ground, I'm looking for when x is 0, or I need to solve my quadratic equation. All right. And what we're going to do right now is I'm going to kind of show you 3 ways to do it. So if you type in this equation into y equals in your calculator, I have screenshots here that I'm going to use so you can kind of go through the keystrokes as well. But what I would like you to do right now is go to y equals on your calculator and type in negative 16 t squared. Whoops. Where did that slide go? Negative 16. Make sure any plots are turned off from previous chapters. Negative 16, instead of t, you're going to use x squared plus 48x plus 400, I believe, was the function. I just want to double check. Negative 16 t squared plus 48t plus 400. Negative 16 x squared plus 48x plus 400. All right, at this stage, the first thing I want you to do is go to the table. So you're going to hit second and graph. Second graph brings up your table. If you're looking for x-intercepts here, you kind of want to scroll back and forth. Keep in mind, with word problems, we're looking for positive times. Oh, ooh, 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 ooh. Oh, man. So we started the object at 400. It went up in the air, and then, oh, man. What happened between 6 and 7? It looks like it went to a negative distance, meaning it plummeted into the center of the earth. All right. Whenever this happens, we know it had to go from positive y values to negative, which means there was a intercept or x-intercept or a solution. So if I'm using my table to estimate, I would say somewhere between 6 and 7 seconds. All right, using the graph, go back, we could do the same thing. So I can hit graph. If your graph looks like this and you don't see anything, keep in mind you can always reset by hitting zoom number 6. Zoom standard will reset your window back to normal. All right. Now, if I look at this situation, again, I don't care about this side of my graph because that's negative seconds. But we have 1, 2, 3, 4, 5, 6, 7. Oh man, our graph also indicates that between 6 and 7, I have a solution. That's awesome. Again, the table and the graph are really nice to kind of get that estimate of my solution. But if I want to actually calculate it, I need to use my calculator program. So I'm going to hit second trace, aka calculate. All right. What I want to calculate is a 0 on my graph. So I'm going to hit calculate number 2. Your calculator is going to run through a series of questions. It's going to ask you, is your cursor left bound? And what I would encourage you to do is kind of move your cursor over. All right. And we know what occurred between 6 and 7, right? And you can kind of watch your y values. All right. So I could hit enter here, or if you want to, you can also just type in a 6 because we know it's between 6 and 7. Either works. After you figure out your cursor or a left bound point, you're going to have to move your cursor to the right. Okay. And I can move it to the right with my cursor like that. Or I can just type in a 7 because I know it's between 6 and 7. Right here, it's almost at 7. I'm just going to hit enter. Essentially, what you're telling your calculator is between those two bounds where you place your arrows there, your bounds essentially, where did it go from positive y values to negative y values? And the third question here is guess. You want your calculator to guess, so you hit enter. And it looks like at 6.7 seconds is a solution. All right. And again, here's the keystrokes to kind of help you follow along. Calculator, left bound, right bound, guess, and you're good to go, okay? And you can either type in numbers or you can move your cursor left and right. Feel free to do whatever you want. Ask me questions if you need, but that is section 4.2. Again, big ideas on 4.2, especially with word problems. You're either going to be looking for the highest point, which is the vertex, or the 0 on your graph, which is your x-intercepts. Just be conscious of the context of the problem, and we'll go from there. As always, check your assignments before submitting. Let me know if you have any questions. I wish you the best of luck.